Today, I want to take you to the most tragic object in our solar system. A world that almost became a star. A world that nearly destroyed Earth. And somehow became our greatest protector. This is Jupiter. 4.6 billion years ago, when the solar system was still young and violent, Jupiter was not what it is today. It was hungry. And it was growing fast. Deep inside Jupiter, the temperature of its core climbed dangerously close to the threshold needed for nuclear fusion, the same process that powers the Sun. If Jupiter had gathered just a little more material, if its mass had increased by about 80 times, it would have crossed the line. Jupiter would have ignited. A second sun would have appeared in our sky. And that would have been the end of Earth. Two suns mean endless daylight. Oceans would boil into steam. The surface would become uninhabitable. Life wouldn't struggle to survive. It would never begin at all. But Jupiter failed. It devoured dust, rock, and gas from the early solar system. Yet always fell just short of becoming a star. Fate stopped it at the edge. And that failure is the reason you're alive today. Because missing the throne of a star gave Jupiter a new role. Guardian of the inner solar system. Jupiter's gravity is so powerful it bends the paths of objects millions of kilometers away. Like an invisible shield, it captures or deflects over 90% of comets and asteroids that wander toward the inner planets. Some are swallowed. Others are slingshot into deep space. Without Jupiter, Earth would be under constant bombardment. Computer simulations show that if Jupiter suddenly disappeared, Earth would suffer thousands of catastrophic impacts within a million years. Dinosaur-level extinction events wouldn't happen once in history. They'd happen every few months. Human civilization wouldn't even get the chance to leave a trace. But here's the twist. Jupiter wasn't always a protector. In the earliest days of the solar system, it was something far more terrifying. A destroyer. As Jupiter formed, its immense gravity pulled it inward, racing toward the Sun. Anything in its path was torn apart. Planetary embryos, worlds that could have become super-Earths, were shattered or consumed. Mars is the biggest victim of this chaos. It could have grown larger than Earth. Massive enough to hold a magnetic field. Strong enough to protect its atmosphere and oceans. Mars might have hosted life before Earth ever did. But Jupiter stripped away nearly 90% of its building material, leaving Mars frozen in time, a small, dry, lifeless desert world. And if Jupiter had continued its inward march, Earth would have faced only two possible endings. Either we'd be trapped by Jupiter's gravity, becoming just another lifeless moon orbiting a gas giant, or we'd be flung into interstellar space, drifting forever in darkness at temperatures near absolute zero. So what stopped Jupiter? Another giant stepped in. Saturn. Saturn's gravity locked into a precise 2-to-1 resonance with Jupiter. The two giants pulled against each other like cosmic rivals in a tug-of-war. Then Uranus and Neptune joined the fight. Together, they halted Jupiter's charge and forced it back into a stable orbit in the outer solar system. This gravitational battle reshaped everything. And it triggered one final, miraculous consequence. As Jupiter was pushed outward, its gravity violently disturbed the Kuiper Belt, a vast region filled with icy objects. Billions of tons of ice were thrown toward the inner planets. Many of those impacts struck Earth. Those impacts delivered water. Scientists now believe that over 60% of Earth's ocean water originated from the outer solar system. Without this chaotic accident, Earth would be a dry rock. No oceans. No life. In 2016, humanity finally met this giant up close. NASA's Juno spacecraft traveled 1.7 billion kilometers, spending 5 years reaching Jupiter. What it discovered shattered everything we thought we knew. Jupiter has no solid surface. It's a colossal pressure cooker, more than 11 times wider than Earth. If you tried to descend into Jupiter, you'd first encounter clouds at -145 degrees Celsius. With winds over 650 kilometers per hour, fast enough to shred steel. Go deeper, and hydrogen gas is crushed into liquid. Deeper still, temperatures rise to 6,000 degrees Celsius. Hotter than the surface of the Sunday. This boiling ocean of metallic hydrogen generates a magnetic field, 20,000 times stronger than Earth's. And then there's Jupiter's most famous feature, the Great Red Spot, a storm that has raged for over 300 years. At its peak, it was large enough to swallow 3 Earths. But today, it's shrinking. Recent observations show the storm twisting, flattening, stretching, struggling to survive. Computer models suggest that without constant energy from surrounding storms, the Great Red Spot could vanish within a few years. When it disappears, Jupiter will lose its most iconic eye. Yet storms aren't Jupiter's deadliest weapon. Radiation is. Jupiter's radiation belts are so intense that any unprotected human would be killed in a fraction of a second. Juno survives only because it's wrapped in a titanium radiation vault. Even then, each close pass exposes it to radiation equivalent to 1 million chest X-rays. Jupiter is a paradox. It should have been a star. But it failed. It was once a cosmic executioner. Now it's Earth's shield. It nearly destroyed the inner solar system. And yet, it delivered the water that made life possible. The failed star that saved the world.